Okay, today we're looking at like terms and unlike terms. So we need to figure out the difference between the two. What's a like term? They're alike, but how are they alike? Yeah, they have to have the same variable, and so not just the variable, but they also have to have the same exponent. Can someone give me an example of what two like terms might look like? What's an example of like terms? If something that has the same variable and the same exponent. Okay, if I have 2x squared, give me another term that would be like 2x squared. So it just has to have the same variable and exponent. Does the coefficient matter? No, so pick another number. 5x squared, sure. What about negative 10x squared? Is that alike? Yes, it doesn't matter if it's positive or negative, as long as they all have the same variable and the same exponent. They do not have the same variable and the same exponent. So can someone give me an example of a term that would be unlike? So if I write 5x, can you give me a term that is unlike that? So it does not have the same variable or exponent? Yes?
5y.
Sure, 5y. What about 10x squared? Is that like or unlike? Good, because although it has the same variable, it does not have the same exponent. What's the exponent of 5x? We can put to the power of 1, exactly. So these two terms are not like terms. We can't combine them because their exponents are different. So one more example of an unlike term that goes along with, that's unlike all of these terms. Anything? 8t to the power of 3. Different variable, different exponent. These two terms are unlike. How do you know? Because of the exponent. They have the same variable, but they don't have the same exponent. Good. What about b? Like or unlike? Good. Like. How do we know? Same variable and the same exponent. The coefficient doesn't matter. It doesn't matter if there's a 25 in front of one of them and a 4 in front of the other one. Okay, what about c? Who thinks they're like terms? Who thinks they're unlike? They're unlike. Because, why? Somebody said it, why? Because this term right here, this is the whole term. It's 3x squared y. Remember I told you terms are separated by addition or subtraction? This is one term, and the second term is negative 3x squared only. There's no y here. It's missing the variable y, so they actually don't have the same variables. Okay? D, like or unlike? Good. Unlike. Why are they unlike? They have the same exponent. Different variables, exactly. E. Who thinks they're like terms? Who thinks they're unlike? Like. Does the coefficient matter? No. What's the variable for E? What's the variable only? X. Right? I can imagine there's a 1 here, but it doesn't matter what the coefficient is. The variable here is x, and what's the variable here? X. What are the exponents? To the power of 1. Both of them are to the power of 1. Therefore, they are both like terms. I tried to trick you on that one. What about F? Like or unlike? Who thinks they're like? Unlike. Good. Why are they unlike? Priyanka? Good. Not all of the exponents are the same. Excellent. Are any of these terms like terms in this expression for F?
X to the power 6 and 9x.
Yes. Good. These two are like, but this third term is not alike. Okay, and G, like or unlike? Good. Like, how do we know? All exponents and variables are all the same. And then finally, the last one, we have a 2y and we have a negative 8y. Like, what are the exponents for each of these terms? 1. Good.
Made with Doodlecast Pro.